Welcome back. In the last three modules, we learned how to build different categories of model systems. From this module onward, our focus will be on ab initio quantum chemistry packages. In the present module, we will learn how to download and install ORCA quantum chemistry package, and we'll also learn how to submit a job in ORCA. Ab initio quantum chemistry methods are computational chemistry methods based on fundamentals of quantum chemistry. The term ab initio means from first principles or from the beginning, implying that the only inputs into an ab initio calculations are type of atoms, position of the nuclei, and number of electrons, just to verify whether it's a neutral molecule or a cation or an anion. Now, ab initio quantum chemistry methods attempts to solve the electronic Schrodinger equation in order to yield useful information such as electron densities, energies, and other important properties of the system. The importance of these methods can be gauged by the fact that the 1998 Nobel Prize in Chemistry was awarded to John Pople for his development of computational methods in quantum chemistry, and he shared the Nobel Prize with Walter Kohn for a method which is currently in huge demand, that is density functional theory. With confidence, we can say that the demand for DFT calculations now supports a small army of computational chemists who collaborate with experimentalists to help them predict or understand laboratory results. And when clubbed with molecular mechanics, they can be used to study chemical process in solution and in proteins. And very recently, the trio, Warshall, Leavitt, and Karplus, received Nobel Prize in Chemistry in 2013 for the development of multi-scale models for complex chemical systems. Now, quantum chemistry and solid-state physics software classification can be done on the basis of whether it's a freely available or a paid software. Further, the choice will depend on what type of basis set we require for our calculation. For molecular, we prefer localized basis set, whereas for solid state, plane wave is the preferred choice. Now, basis set is basically set of functions which are used by the package to create guess wave functions. An example of basis set can be collection of functions corresponding to hydrogen type orbitals. Now, when you solve Schrodinger equation for hydrogen atom, we get the following functions. This is the function corresponding to 1s orbital, which has a spherically symmetrical distribution of electron density around nucleus, resulting in zero angular momentum. This is the function for 2pz orbital, which has dumbbell type distribution of electron cloud, and the corresponding angular momentum is under root 2h upon 2 pi. Although most of the d orbitals have dumbbell type distribution of electron cloud, but the dz square has two lobes along the z-axis with a ring of high electron density in xy plane, and the corresponding angular momentum is under root 6h upon 2 pi. But none of the ab initio quantum chemistry packages use them. Rather, they prefer Slater type orbitals or Gaussian type orbitals. Now, Slater type orbital has e to the power minus zeta r variation, whereas Gaussian type orbitals has e to the power minus zeta r square variation. The angular momentum is controlled, and the shape also is controlled by the ABC variable. If A plus B plus C is equal to 0, it will have S-type angular momentum. If A plus B plus C is equal to 1, it corresponds to P-type shape and angular momentum. If A plus B plus C is equal to 2, it will correspond to, or it will mimic d-type orbitals. But for modeling extended infinite systems, for example, a unit cell with periodic boundary condition, we require a plane wave basis set. Now, the most common among the open source free label codes are ChemIS, Turbomole, ORCA, which use Gaussian type orbitals. Among the plane wave, Carpanilo molecular dynamics, Quantum Espresso, Vian 2K codes are used in demand. There are also codes with both the features. Example includes CP2K, NWChem. Now, among the commercially available software, ADF, which stands for Amsterdam Density Functional, they use Slater type orbitals, whereas the rest, Hyperchem, QChem, Gaussian, Spartan, they all use Gaussian type orbitals. VASP, which stands for Vienna Ab Initio Simulation Package, using plane wave basis set, has the maximum user base worldwide, mainly for solid state physics calculations. Now, information about whether it's a free or paid and the features available in a particular software, you can just type list of quantum chemistry and solid state physics software in Google. You'll be directed to this particular page, which has a table listing all the important packages, giving information about whether it's a freely available software or for academic allowed for academic purpose. ADF, for example, it's a commercial software. And then you have another table which lists what are the bases they are using. For example, ADF, look at that, they use Slater type orbitals. And what are the calculations they can do? Whether they can do a periodic calculation, molecular dynamics calculations, semi-empirical calculations, Hartree-Fock methodology, then post-Hartree-Fock methods, Moeller-Plesset perturbation theory method, coupled cluster method, and then the present flavor is DFT-based calculations. And if you want to simulate an excited state or you want to get absorption spectrum, then you need to perform time-dependent density functional theory. So in this particular workshop, we are going to use ORCA ab initio quantum chemistry code. You can do DFT calculation. Also, you can also perform semi-empirical electronic structure calculations. Now, this ORCA has been developed by Frank Nesse group from Max Planck Institute, Germany. And the increase in website traffic per day demonstrates its rising popularity ever since its launch in 2013. So now let's try to learn how to install this particular very important ab initio quantum chemistry code.